Okay, this part is on rectangles. So from that previous handout, we're moving on. We talked about parallelograms and how to find all the different missing angles and whatnot in here. Now we're on to rectangles, which is a type of parallelogram. So it still has all the properties the parallelogram has. And in addition to that, it has two extra properties, which we're going to write here for the 2 plus these. So go ahead and write those in. Okay, and we're going to draw a little sketch here and kind of go through what some things are equal. Which things are equal? So we already know from a parallelogram opposite sides are equal. I'm not going to write any things that we did before in the parallelogram one, but some of the new stuff. So we have these corner angles are all right. And the diagonals, if we draw those in, those are the same exact size. So these are all the same. Because before, these two are the same, and these two are the same. But now, since the diagonals are the exactly same, all the halves would be equal. Okay. So, doesn't look like I got my pencil back. Yes, I did. Alright, so since this is an isosceles triangle, we have 2 sides the same, which means on this triangle, if I write it in pencil, 2 angles should be the same. So the 2 angles that are the same on an isosceles triangle are the 2 across from the congruent sides. So this angle will be the same as this angle. Then from a previous property that we talked about, alternate interior angles are the same. So this is alternate interior with this, and this is alternate interior with this. So all 4 of these angles are the exact same on a rectangle. These 4 angles are the different, but they're the same as each other. So these are all the same because, again, they're part of isosceles triangles and alternate interior from each other. So that condenses our work down for finding angles. All of the angles have to total 90 degrees in the corners, and then there's only really 2 different types of angles besides the 90. And then in the middle you actually have the vertical angle is the same, and those are supplements to the linear pair. Okay, so we're going to use that, and then we're also going to use the fact that we can, since we have a right triangle, when we cut these in half, we can use Pythagorean theorem to solve for unknown lengths. Okay, so that stands for Pythagorean theorem if you want to write it out. Okay, so if we do a couple examples of the rectangle. Below is a rectangle, find the missing measures. So they don't give us any angles and they don't care about any angles. All they care about is segments. So we know off the bat these are equal, because on a parallelogram opposite sides are always equal. And we know all the segments in here now except for these diagonal ones. But if I take any corner, which is a right angle, and look at the triangle that makes up that corner, I can separate that triangle out and solve for the unknown side. So in this case, SQ would be this side, because this is PSQ. Oh, okay. Hello. And then we would do the Pythagorean theorem to solve this side. So it's going to be 10 squared plus 24 squared equals C squared. Okay, and then we would solve the Pythagorean theorem for C. So 100 plus, so 24 squared is 576. So 100 plus 576 equals C squared. So that's 676. Square rooted is 26 exactly. So C is 26. So S to Q is 26, which means the halves are 13. And these other halves are 13. Because we have this same right triangle on this side that we had on this side. Okay, so QR is 10, and SR is 24. And SQ was 26, 26, and PT was 13. QT, sorry. So if you're given anything with sides, you can solve using the Pythagorean theorem for unknown side lengths. Okay, if you're given anything with angles, then you just want to reference which angles are congruent from our figure, but you eventually do have to remember which ones are congruent. So since these are equal in length on a rectangle, these are all 27s. Okay, then your corner angles are all 90s, So these are all the complements of 27. So 90 minus 27 gives us 63 for all the rest of these. And then if we cared about any of the middle ones, which it looks like, yeah, we do have to. So we can use like this triangle, and we know two angles in the triangle, so we would figure out the third angle by doing 180 minus those two. So 54, 54, and then 180 minus 54, which is 126 for both of these. Okay, then you can fill it in. So go ahead and pause it, fill those in. Make sure that you can fill in the right numbers for these angles, because naming the angles, some of them use the same letters, but they're talking about a different angle, so you have to be able to really identify which angle they're referring to. Okay, and then pause it, just check. So either Pythagorean theorem or some angle stuff like this for these problems. Let's do one more example. Well, two more, because 4 is a little bit different. So 4, they only give you one angle. All of these only give you one angle, but these are all the same. So if we know a triangle at the top, let's say that triangle there, we know the total is 180, and we know the vertex angle, which is different than the other two, but the other two are the same. So we can figure out what those other two angles are. So we would take the 64 from 180, and we have 116 degrees to split evenly between two angles. So it's going to be, what is that, 116, so 58 degrees for both of these. And both of these on a rectangle. And then the corners again are 90, so we do 90 minus 58 to get the corners, and it's going to be 32. These angles together with these make a straight angle, so it's 180 minus 64 to get these. Okay, and then you can fill those, and I'll let you do that. And then number 5, with the GB, this whole thing being 42, AD is 26. So to find any kind of side length, well, all of these are 21s, because all the diagonal pieces are the same. These are each 26. But you'd use Pythagorean theorem again. Okay, so then you would do Pythagorean theorem, and this time you know C. So C is always across from the 90, no matter, it's always across from the 90 for every right triangle. So you would do 42 squared and 26 squared. Okay, so you square everything, and then subtract from both sides, so you get 1088, and then square root it. We're going to round these to the nearest tenth, which it's a 9 here and an 8 behind it, so we bump this up to a 10, makes this a 0, this adds a 1, so it's 33. Okay, and then the angle part, DAE, is 52, so there's going to be 4 52s. And all the rest of them are going to equal 90 with that. 90 minus 52 is 38. Okay. And then if you add these together, 104, that's going to be this angle actually. And then the difference of that in 180 is going to be this angle, 76. 76. Okay, so you can fill those in. Okay, on the back you're doing the same thing. You're having to figure out if you're setting the two things equal, like in this case, you would do that, solve for x, substitute it back in. Or if you have to, like on this one, these are the corner angles, they have to add together to equal 90. So you have to figure out kind of how to do it and then set up the equation. On the challenge ones on the bottom, this one, the hint is that this is a right angle. So look at the triangle And the hint for this one is to find all the angles as if you were doing the previous page. So ignore this for a second and see if you can get all of these angles in here. And then whatever you get for this angle, whatever degrees you get, set it equal to this, 5x plus 7. And then you can solve for x. So that's my hint for that one. So that's rectangles. Okay, in rhombus, we're going to copy in rhombus properties and square properties. So you can, I'm going to copy these in real quick and then, yeah. I'm also going to copy the square ones in the back. Oh, they're already in here. Alright, so a rhombus is a parallelogram where all four sides are equal. The diagonals are perpendicular, which means they cross at 90. And the diagonals bisect the opposite angles. Okay, so that means that this angle right here and this angle are getting cut in half. So these are equal. These angles are all the same. And these angles are all the same. Okay? So that's going to help us solve different things because all we need is one angle. We'll be able to figure out all the ones inside. And then since we have these right angles here, we can do the Pythagorean theorem for the quarter triangles. So there's 4 of them to find any missing sides we don't know. Okay. So alright, so we'll just do 2 of these examples. I think it's sufficient. Just trying to see how many I did in the previous class, but I don't have that here, so yeah, I do. Sweet. I just did 2. Okay, so I just did 2 examples of this, and then wow, I didn't actually even do that. Okay, so each quadrilateral below is a rhombus. Find the measure, missing measures. So these are side lengths. JK is a segment, or segment length, sorry, and 7. So unlike on a rectangle, these aren't all 4 equal. But these 2 are still equal because it's a parallelogram, and that's true of every parallelogram. So these 2 are both 7, and this is a right angle. So we can figure out, using this right triangle, what the last side is. So we have a 12 and a 7, and we're looking for x. So we're going to use the Pythagorean theorem. And x and 7 are our legs that border the 90, so 12 is by itself. Okay, so I'll let you do the Pythagorean theorem. We've done it a lot, so I'm going to quickly go through it. So it's 9.7. You can pause it, of course, anytime you need to slow down. Okay, Mn is 9.7, so is Nk. So all these sides on a rhombus are the same, and then we have everything. So go ahead and fill those in. I'll let you do that. I'm going to burn my nose. Sorry. And I'm going to do one angles one. So that's a segment one. You can always use the Pythagorean theorem for any of the 4 right triangles that the rhombus creates. And then for the angles, we already kind of drew the angles up here, but the ones that match would be these 4 and then these 4. So 3, 4, and 5 are all 38. 3, 4, and 5. And then because these are all 90s on a rhombus, the diagonals are perpendicular. Then we have a triangle with a 90 degree and a 38. So we can use the triangle angle sum to find out the last angle. Minus 90 minus 38. So 52 degrees is all 4 of the other angles. Okay. And then on a square, the nice thing about the square is that lots of equal stuff. square has all the properties that all of their three others have. So, all the sides are the same. Excuse me, I'm sorry. Can't pause it fast enough. Okay, all the sides are the same. The diagonals are all the same. And because these are 90s getting cut, bisecting the angles, all these angles are the same. These are all 45s. Okay, and you get the picture, they're all 45. And then in the intersection, it's 90. So anytime they ask you for any angle, it's either going to be 90 or 45. So these are all 90s. These are all 45s. Okay, but they give you AD is 11. So to find BC, well, these are all going to be 11. And then we have a right triangle here, so we have 11 and 11, and we're going to do our Pythagorean theorem. .6. So 7.8, if you divide it by 2, is all the halves. Okay, and that's the gist for the for the square. You have all 45-degree and 90-degree angles, but then to find the segment in the middle, you just do the Pythagorean theorem and cut it in half. Okay, so that's it. Hopefully the rest you'll be able to figure out using those properties. I need to get some rest and drink some orange juice. Hopefully that'll help the allergies. And I'll be here after school on Tuesday instead of Monday this week since we have a holiday.